In today's first ever Ruby Love screencast, I'd like to talk about the how and why to avoid ifs. More specifically, I'd like to talk about using object-oriented programming to get rid of conditionals. I have a file prepared here. And this is very typical Ruby code. We have a class called animal. We have a reader to read the type of animal. When we create an animal through the initializer, we pass a type, and we create a stomach, which is just an empty array. Then we have a method called eat, in which we pass some food. And now we come into mega conditional land. This is okay to read, but I don't like it. It's very horizontal. It's got 1, 2, 3 different places where code can branch, which means that if I'm TDDing this, I'm going to be writing quite a few tests against this, probably 3 or 4. Let's go down to the privates. And inside of here we have a function called digest, which just takes a piece of food and then shovels it onto the stomach and then returns the string yum yum. We also have an internal private method called vomit, and that one just returns barf. Then we have another class that's called food, and it's got an add a reader called type, and when you create a piece of food you pass in a type and it sets the type. So it's used like this. We create a piece of meat by calling food.new and we pass it the symbol meat. We can create a veg object and set that to food.new and pass veggies. So now we're going to have 2 food items. One is going to be of a type meat and one is going to be of a type veggie. Then we'll create 3 animals. We've got a cow, a dog, and a cat. So the cow is set to animal.new herbivore because cows only eat plant matter. A dog is an animal.new omnivore because anyone who's ever owned a dog knows that they will eat anything. Well, except for their own dog food, I suppose. And then you have a cat. And a cat is a new animal, and it's a carnivore. Then we have a list of foods and a list of animals, and we're simply going to iterate over those foods, and then iterate over those animals, and then force feed each of these pieces of food to the animal. Now let me talk about some things that I don't like about this code. I don't like that we have essentially a case statement here where we're going to look at the food type and then we're going to look at the animal type and make sure that it fits the correct type of animal for the correct type of food. It's a lot to wrap your head around. The other thing I don't like here is we're shoveling food onto a instance variable stomach, and that's state modification, and I don't like state. If I can help it, I stay with idempotent functions, things that if you give it the same value, it will continue to give you the same return, no matter what the outside world looks like. So, I've done a series of revisions here. If I do a git branch, you can see that I've got revisions 1 through 8, and if I check that out, we now have revision 2. And the idea of revision 2 was now we're going to add more functionality to the original code. And the reason that I chose to do this was to show you how you can start off with a very simple piece of stateful conditional code, and rapidly those conditionals and those pieces of state will start attracting behavior and start attracting code paths. So before we just had a type, now we have a type and a size. We still have just a primitive function or a primitive array for the stomach. We still have an eat variable that just takes a piece of food and then it checks to see if the animal can indeed eat that kind. And if it can, then it also checks to see if the animal is already full. And if it's not full, then it goes ahead and digests the food. And if it doesn't eat that kind of food, or the food is incorrect, or the animal is full, then it vomits instead. So then we have to have a way of checking if the animal is full. And the animal is full based on their size. So if you have a very small size animal, its stomach can only contain 1 item. Okay, so it's going to be full if there's more than 1 item in their stomach. Actually, there can never be more than 1 item in their stomach. But if there is an item in their stomach, it's going to be full. So we can fit 1 in here, we can fit 2 in the medium, and we can fit 3 pieces of food in the large. This code hasn't changed. We still shovel the food onto the stomach. We pass a yum yum if it's good. Otherwise, we return the string barf and we vomit if it's not good. The food has not changed. It's still just a type. We still have meat and veggies. Now we're passing the size in. So a cow is an herbivore and it's large. A dog is an omnivore and it's medium. And a cat is carnivore and it's small. We're going to put a whole bunch of foods onto this now. We got a meat and a veg and a meat and a veg and a meat and a veg and a meat and a veg. So we have 8 items here in the foods. We have 3 items here in the animals. Again, we're going to iterate over the animals. We're going to iterate over the foods, and then we're going to see if that animal is full. And then we're going to feed the animal stuff. So if we run this, it'll go through the list. And you see that it's feeding meat to a large herbivore, which of course makes the herbivore barf because they don't eat meat. Then we're going to feed veggies to a large herbivore, and it's going to say yum yum. Then we're going to feed meat again to the large herbivore, and it's going to say barf. We feed more veggies to the herbivore, and it says yum yum. Try to feed meat to it again, and it barfs. Feed more veggies to it, yum yum. Feed meat to it, it barfs. Feed more veggies, yum yum. So the herbivore doesn't get full. Now we switch over to the carnivore or to the omnivore, and the first 3 pass because we feed it a meat and a veggies and a meat. It can handle those pieces of food no problem. But when we get to the next piece of food that we try to feed it, it's going to barf because it's full. So you can see now it says feeding veggies to a full medium omnivore. So it's a medium omnivore that its stomach is already full. Therefore, it's going to barf. And if you scroll down to the bottom to where the cat is, you feed it a piece of meat and it's happy, and everything else you try to give it, it barfs because it doesn't have any room in its stomach. So there's more I don't like about here. First off, our conditionals gravitate or attracted another conditional. And this is what I don't like about conditionals, is you put a simple if statement in. And then some joker, which could be you, could be some other developer, is going to come by tomorrow, and they're going to add an if else. And then a couple days later, somebody else, or possibly you, is going to go back and look at this code and say, I need to add a new piece, and it looks like it fits here, so let's add another conditional. So now we turn an if else into a case statement. Before you know it, it gets completely out of hand, and you've got branching all over the place, and every time you have code branching and every time you have state modification, you're in a world of trouble when it comes to debugging to find out what the actual rationale of that application is at that moment. So now I'm going to look at revision 3. And in revision 3, let's see what I've changed. So we still have an animal. It has an add or reader of size. It looks like the type is gone. We still have a stomach, which is an array. We have an eat method, passes food, and it just vomits, which is very strange. We don't actually have any digestion here. We only vomit. And then we have this full statement, which of course is a bunch of conditionals. And then we still have our digest. We're still shoveling food onto the stomach and returning yum yum. We have a barf, or a vomit, and it barfs. And now we get into where we're going to concretize these. A concretion is when you're going to get more specific about the type that you're dealing with, rather than having an animal, which is a very broad stroke and can include a lot of different species on this planet. Carnivore cuts us down quite a bit, because you're either a carnivore, you're an omnivore, or you're an herbivore. So if you're a carnivore, we're going to still call super to animal. When we call super to animal, you're going to see that it does create ourselves a size and a stomach. Okay? Then, if the food type is meat and we're not full, we're going to digest that food. Otherwise, we're going to vomit. So if you create an animal and you try to feed it food, it's just going to vomit, because we don't want this class used directly. It's more or less just a class to build stuff with, so you don't actually instantiate it. Now we have another concretion where we go from animal to herbivore. The exact same thing happens. You shovel it or you give it some food to eat. If the food is veggie and they're not full, then the herbivore will eat it. Otherwise, they're going to vomit. And then the omnivore has the same thing, only everything you feed them, they'll eat. There's no vomiting going on, unless, of course, the animal's full. So when we run this code, everything still passes. So we didn't really change anything. We changed the implementation under the hood, but the interface, the public interface of this never changed. So it still works pretty much the same as it did before. We just pushed some complexity down into some concrete classes of omnivore, herbivore, and carnivore. However, this is still a general class. There are a lot of different animals that are omnivores, and they're not going to all operate the same way. I also don't like how the size is attributed to the animal, not the stomach. What happens when the size is attributed to the animal and not the stomach is this big conditional block, okay? If the animal was more specific and it had a specific stomach size rather than a stomach in an animal with a size, we can push this complexity down even further. So that's what we're going to do here. We're going to jump onto revision 4. We still have an animal. We still pass a size. We still have a stomach. It's still a class that's just meant for building stuff. It's not actually going to be implemented directly. So nothing really changed there. However, if you notice, we have a full up there, and now we're going to return vomit if it's full here. So what happened is we lost the ability to, in revision 3, to determine if the animal was full. So if I do an ACK on this and I look for ifs, there's 1, 2, 3, 4, 5, 6 ifs. We can do better than this. The way to continue to remove the if statement is to get away from these abstract classes and move into concrete classes. So let's do that. Let's switch on to revision 5. Let's take a look at the code again. Okay, so now we have a stomach. It's a class, and it has a contents. And we override, or I should say define, the shovel operator to shovel food onto the contents of the stomach. Now we're going to concrete that stomach size, and we're going to say that we have a large stomach, which if it will be full if the contents are greater than 3. We have a medium stomach, which will be full if the contents are greater than 2, and we have a small stomach, which will be full if the contents are greater than 1. Now we create the abstract animal class, and in the initializer, we still pass the size, but instead of setting the size to the animal, we're going to now create a stomach that's based on that size. I'm going to use metaprogramming here to do this. This is the way that I perform convention over configuration all the time in Ruby, and I learned this from Rails. So we're going to do an object const get, which is just going to return us a constant from our string. So we're going to do size.capitalize to go from a symbol of, say, colon small to capital S lowercase m-a-l-l stomach. So we create a small stomach or a medium stomach or a large stomach for the animal. The size of the animal is now delegated to the size of the stomach. And it's still an abstract class. So if we call eat on an animal after creating an animal directly, it will just vomit. And this is a way of saying that this is an abstract class and you're not supposed to actually instantiate it. Ruby doesn't really have a way of specifying that a class is simply an abstract and should not be implemented on its own. There are ways of doing this. You could, in the initialize, if they try to create one of these without a superclass, you could raise an error and say that this is an abstract class. I don't really like doing that kind of stuff. The point of using Ruby is to have the freedom to make your own constraints and then use those constraints to better your programming, not be constrained by the language itself. So we still have a digest, which is going to just shovel food onto the stomach, same as before. We still have a yum yum. We still have a barf. Okay. The difference is when we shovel food onto the stomach is no longer just an array. Stomach is now an actual class with a shovel, which pushes the value onto the contents. So Now we're going to move on to some more concretes. Back down to the carnivore. Not a whole lot has changed here. We just call super, which will pass the size on through. Now we're going to do a little bit different though. Rather than have a statement in here for carnivore that says, well, if you give it food, let's check the type of food, and then we're going to either vomit or eat it based on the type of food, we can do the exact same thing as we've done up here for the stomach size by creating a constant out of the text that we have through convention over configuration to create a stomach. In this case, we can have a simple public method called eat. If the animal is not full, it's not going to vomit. It's going to simply do eat underscore food type and pass the food. So it will only respond to the types of food it knows how to deal with. If you want to add a new type, say eat poop, right? You're going to have to add a method here called def eat underscore poop, passing food, and then you're going to have to say what happens when you do that. So in the case of a dog, probably smiles. In the case of a human, probably vomit. We do the same thing for herbivore because an herbivore can only eat one type of food. So we're going to send to a method, a private method, that's going to be eat underscore food type. And this one's reversed. If you feed it meat, it vomits. If you feed it veggies, it digests the food. An omnivore, of course, it does not need any special case switching like that because it will just digest anything. Food is still completely an abstract class in the sense that a food is a food and you instantiate it with either meat or veggies or something else. These are semi-concrete, however, they're still quite abstract as far as I'm concerned because, like I said before, herbivore, omnivore, and carnivore, it divides up the animal kingdom, but it still it's not very concrete. Okay, so let's run our code here. And everything still works. If you pass, only now it's going to spit out what type of stomach it has, right? So if you feed meat to a large stomach herbivore, it's going to barf. But you can feed veggies to a large stomach herbivore 3 times before it gets full. And all the way down to the cat, which you can only feed it 1 time and then it gets full, which means that feeding meat to a small stomach carnivore, right? Let's take this a step further. First, before I do that, I want to see how many ifs we have at the moment. So now we're down to 3 ifs. And if we look back at the very first version, git reset -- hard because I changed the file. Let's go back to version 1. Let's do our ACK again. It's only showing 2 ifs in this version, but you can see that they're quite long. And then when we go to revision 2, which is where we added size, it gets larger still. Now we will go from 2 to 5. And this is what I typically see on abstract classes, is every time another developer adds any kind of new functionality, you basically get an exponential growth on your conditionals. Now, I don't know about you, but exponential growth on conditionals is a terrible, terrible thing. So let's go back to revision 6. Now we only have a single conditional in the whole file. So let's see how that was done. We still have an abstract stomach that knows how to barf and it knows how to digest. It's only going to digest if it's full. Here's our single if statement in the whole code at this moment. So digest has moved up onto the stomach and vomit has moved up onto the stomach. These were defined before on the actual animal. It does not make sense to have them on the animal. It does make sense to push that complexity down into an object that is the stomach. We still do the same thing. We vomit if it's full. Otherwise, we shovel the contents or the food onto the contents, and we return yum yum. We still have concrete classes for large stomach, medium stomach, and small stomach. We still have an abstract class for animal, which is going to generate a stomach based on the size that you give it. It's going to delegate its size to the stomach, and it's going to delegate whether or not it's full to the stomach. Now we go back into a semi-concrete classes of carnivore, and there isn't any change here. Herbivore, there isn't any change here, and there isn't any change on the omnivore. When we run our code, we get the same results that we were expecting. So nothing is broken yet. We've edited the code 6 times now, and the code still works. and we're creating more objects and pushing the complexity down into those objects. And for every object that we create, conditionals vanish because each concretion is going to destroy conditionals. That's just the way a concretion works. Let's go on to revision 7. There are no if statements in revision 7. We've gotten rid of all of our conditionals. Well, technically there are conditionals, but they're in convention over configuration metaprogramming instead. Now, if you give say you give a piece of food that's poop, right, and the animal does not understand how to eat it, it's just going to blow up, which is what I would want. I would want a stack exception if you try to give it food it doesn't understand, rather than, say, return a nil and then have nil dispatched all over the place. So dispatching methods on nil, obviously not good. Conditionals, not very good either. So how did we get rid of that if? We still have vomit for barf. We still have a digest. And now we're going to do another piece of metaprogramming. We're going to say that you're going to digest when, look at the value of full. It's either going to be true or false, right? So we digest when true. And this kind of reads backwards because full is the positive. So we're going to say digest when true and then vomit. I don't actually like that. So I'm going to make this change right here, right now. And I'm just going to say that if it is not full, which means that then I can do this. And I run the file and it still works. So what I did was I just changed this to not full so that it will digest when false, which is a vomit, and it will digest when true, which is go ahead and shovel the food on and return yum yum. So we still have a concretion here. It's the large stomach, a medium stomach, a small stomach. We have an abstract class called animal, which just delegates down to its stomach contents. We have a carnivore that's pretty much unchanged, herbivore and omnivore that are pretty much unchanged. But now we are going to concretize these classes even more. Rather than instantiating an omnivore and assigning it to a variable called dog, how about we just make a dog class? The dog class is going to inherit from omnivore. It's going to have a single method, which is an initializer. We're going to call super, and we're going to concretize its stomach. I know that if I have a dog, it needs to have a medium-sized stomach. I don't need to do any special things. I might later on take dog even further, right? You might make a Chihuahua, which is a type of dog. But now you're going to pass a super tiny stomach. You might have a Great Dane, which would inherit from dog. But inside of that initializer, you're going to pass a very large stomach. And anybody who's had a Great Dane knows that they eat a lot and they poop a lot. Which is probably why my parents took my Great Dane away when I was a little kid. So we have the cow concrete class, which is an herbivore, which is the semi-abstract class. We have an initializer here, and again, all its job is to specify a very specific stomach. So we know that a cow has a large stomach. Now, we might need to get in at some point some business logic that talks about how that stomach digests, in which case we might want to create a large ruminant stomach or a large, I don't know, what would you call a non-ruminant stomach? I don't know. I know a little bit about ruminants because I used to raise cows. So we also have a concrete class here, cat. Again, this is a semi-concrete because you could have a Siamese and you could have another type of cat. They might not have the same stomach. One of them, for instance, might be highly allergic to tuna. Our food class is still completely abstract. We just say it's a meat or it's a veggie. But now when we create a cow, we're creating a new cow rather than some kind of an omnivore animal and passing in all kinds of stuff, right? So now we just say cow.new. We don't need to pass it anything because the cow concrete class knows what type of stomach it has, and it knows what size that stomach is. Same with the dog and the cat. We'll iterate over them again, and nothing is broken. Everything's the same. When you try to feed to a large stomach, you can feed quite a bit to it before it gets sick and barfs because it's full. However, you can only feed certain types of food to it, otherwise it'll barf. You can feed you can feed pretty much anything to a dog, but after you get so much stuff in the dog's stomach, it's going to barf. So our code still works, everything's still fine. And again, if we do an ACK, there's not a single if statement in this code base. I'm pretty happy where this is at. I think that if there was anything I would do different, it would probably be to make some concrete food types. So I could do that by saying that I have a meat food. And now I don't really need that add a reader. I am going to need an initializer. And it's not going to take anything. And it's going to just set the at type to meat. However, I think it's better to call back up through super to the abstract class and just say that we're going to pass meat, if I can type. So now we have a concrete class, meat, that inherits from the abstract class food. And we're going to also have ourselves a concrete class for, say, vegetation, which is going to be veggies for its type. And now, instead of creating a food new and passing meat, I can just say I want to pass meat.new. And we're not going to create veggies, we're going to instead create vegetation. And if I run my code, everything still works. So by concreting these classes and then passing them in, we essentially get rid of parameters that you have to pass in to configure the object, which in turn gets rid of the conditionals. This is an OO style that I think works very well with Ruby. You have shallow inheritance. Each class is a concrete version that's going to have methods that's going to be very explicit about it. The difference between implicity and explicity is always going to come down, at least in Ruby, to how concrete you make your classes. The more abstract your classes are, the more conditionals that you're going to have in them, the more implicit code you will have. The more concrete a class is, the more explicit the code inside is going to be, and it will have fewer conditionals. So I think that's about where I'm going to leave it today. That's one way of how and why to, well, we didn't really get into why we would avoid ifs, but we did talk about how you can avoid ifs. So maybe in my next one, I'll talk about exactly why you might want to avoid ifs. So that's it for today, and I will see you next week.